Okay, so welcome to day 7 of my Inventor IO 30 Days Lost in Space adventure. Today's lesson we're going to go over a couple of new things that were not explained in the previous videos. One of them being an unsigned integer value and the other being a double value. A double value allows you to use decimal points in your numbers, whereas an integer value is a whole number. An unsigned integer value is a positive only number, whereas a regular integer value will go to say negative 32,000 to positive 32,000. An unsigned integer value will go from 0 to, I believe, somewhere around 64,000. There's not really much difference on the board from a lesson standpoint, but I'm going to add my own little flavor to it after I go to the computer view and we go over the code. I'll go back to the overhead and I'll just show you what I'm trying to do here as opposed to what they show in the lesson. Okay, so we're back to the computer view, and if we scroll down, I've already gone through the video, and when we scroll down we look at the diagram. The diagram hasn't changed, and down inside of the code section there's a couple of new things in here. One of them being they created a function. So instead of just having the void setup and the void loop, where the setup will declare all of the static values and the loop will just continue to repeat until infinity, this function here is just something that can be utilized inside of our code somewhere just by calling up the function with the parentheses, and the system will know to search, in this case, this print battery percentage function, which houses the values inside of them for a serial print, for the, in this case, a battery level percentage, and a percent sign. So if we go to my side-by-side, I'm going to type this stuff in because it's helpful for me, and I think it's helpful for you guys to just watch as I explain what each of the callouts are doing. So the first thing we're doing is we're just basically building on the program that we had yesterday. So we have an integer value called sensor pin, and that's going to analog input A0. We have another integer value called onboard LED, and that's equal to 13, which was the output pin that we were using for the onboard LED to flash. He actually doesn't even use this in the example, but I'll change this to external LED, and I'll utilize that. I'll use that on my board. The next thing is another integer value called sensor value, and they're setting that to 0. And then we have two new integers called unsigned int called battery capacity, and he's just using an arbitrary number of 50,000, with another unsigned int called battery level, and setting that to a 0. So that's just a declaration for this battery level to be set at 0. So when you run the program, it automatically starts at 0%, and then it just climbs up to the 50,000 value, but then there's some mathematics in the additional function that was created to get the 100% readout. Below that, I call up another void, and this void is going to create the function that gets called up in the else condition down here So down in this if conditional, we have a battery level greater than or equal to battery capacity, and if that condition is met, then it will print out fully charged. And then under that, just forces battery level to be equal to battery capacity to prevent any type of overflow from the integers counting up too high. But if that condition is not met, it goes to the else condition and it jumps up to this print battery percentage function up here that will print out the current percentage of the quote-unquote battery level. This is all hypothetical. So we'll call this void print battery percentage, open close parenthesis, and then give it curly brackets, because that's how your functions should be called up. So we have void, in this case setup, with parentheses. Inside the parentheses you can actually pass argument values, just like in regular C. We haven't gotten to that yet. I hope they do cover that, because that's still a little green to me. Inside of that sub function, we'll call up serial dot print. We'll call up a double, and we'll call up battery level. Now, calling up this global variable, even though it's an unsigned integer called battery level set to 0, down in this function we convert the unsigned integer value to a double, which is a decimal place value. So just inside of this function, we're declaring this as a decimal place value, even though here we called it an integer. And then from there we're just doing some math. So we're saying battery level divided by, we're converting battery capacity to a double inside of this function. And then we're multiplying that by 100. And I actually think the parentheses should go that way. Let me look. Yeah, so I had a boo-boo in my first program. So this is why we do it more than once. From there, we do a serial print line with a percent sign. And remember yesterday, I said if we do a serial print and inside of the quotes we have percent sign, and inside the quotes we have the percent sign. If I put and inside the quotes we have the percent sign, but if I put a /n inside of this call out here, it's the same as saying print line. So again, I can show you this. If I take out the print ln, compile it, re-upload. Yeah, so here we go. So print line with a /n inside of the double quotes will give us a double line space. And then inside the function, I just threw a delay of 50. Their code, they put the delay further down. They put the delay down here, just outside of the if statement. So if we wanted to copycat theirs, we can just take that and throw it down at the bottom later on. Inside of our setup, we do a pin mode. And in this case, we have external LED, set that to an output. We'll do our serial dot begin 9600 transfer rate, and that's all we need in our setup. Now inside of our loop we say sensor value equals analog read sensor pin. So sensor pin is A0. We're reading the value coming in on the analog input, and we're assigning that value to sensor value, which at the top is declared as 0. Underneath that, we say battery level. And then there's a new control, which is plus equals. And plus equals sensor value is the same as saying battery level equals battery level plus sensor value. So it's just shorthand for this variable equals itself plus this value here. Underneath that, there's an if battery level is greater than or equal to battery capacity, open close bracket. We put serial dot print line fully charged, and then to prevent overflow, battery level equals battery capacity, because without that you get some weird numbers that pop up after 100%. Underneath there is an else, open close bracket, and then here in the else is where we call up that other function we created at the top of print battery percentage. And then underneath all of that, when it goes to loop around, if we throw in a delay of 50 was a little quick, we'll say 100. From there we can compile, see if there's any error messages, and in this case I have an error message because I missed a semicolon at the end of the battery level plus equals sensor value. So I'll recompile. That time it was happy. Upload. And if we go to the serial monitor, we can see that it still counts up quickly, but it's not as quick. I'll set that to 250. And what I'll do is I'll turn the lights out. So we'll see here that the percentage goes up pretty slowly because there's not a lot of light getting to the sensor. But if I turn the light back on in the room, you can see that the numbers go up pretty quickly. So what I want to do, just for sake of argument, I want to utilize this external LED and here say digital write external LED high. Nothing crazy. I just want to turn the LED on when the percentage reaches 100, just to keep things fresh in my head. I'll upload that. I'm going to wire in the additional LED, and technically I don't have to wire in the LED, because once the monitor hits 100%, the internal LED will turn on, because the internal LED is tied to pin number 13. So I'm looking at it now. We're getting to 100, and the internal LED goes on. So I know that the code's going to work, but I want to wire up the LED anyway. So let's go back to the overhead, and we'll wire up the LED. Okay, so I decided to freestyle a little bit more than I thought. So what I did was I wired up an LED on this side to pin number 12, and then I wired up an LED on this side to pin number 13, and pin number 13 is going to be my full, and I'm going to use the red one to be my not full. I haven't tested this yet, but what I did was I changed the name of the external LED to external full LED. I created another integer called external low LED, and then I created another integer value called delay blink, so I could put a delay with a common timing in multiple places in all of my functions. I compiled the code. Everything looks okay. The additional stuff was I told the red light to blink inside of the new function, the print battery percentage function. So as it's printing the percentage, it will also flash the red LED light. So I'm going to plug this in. I have yet to test it. Let me upload it. I'll call it my serial monitor. So right now we can see that the red light is blinking. I'm watching the counter. We're at 40%. We're almost to 100. We're at 75, 80, 90, and now we get the blue LED. So as it's charging, much like a charger for a cordless drill, you plug in the battery, what happens? The charger will usually flash to let you know that it's charging, and then it will light solid to let you know that it's done. Or another light will come on, a green light or something will come on to let you know that it's done. So that's what I've got going on here. I have listened to the first handful of lessons, and I'm pretty sure that what we're going to do tomorrow is utilize the multicolor LED that comes in the package. This one here, we're going to utilize this to basically do the same thing. But instead of flashing, I think it's going to go red for low, and then yellow for halfway, and then green for full or something like that. But this is a multicolor LED. I think it's red, green, and blue. So we'll have to mix the primary colors to get the in-between colors. So we'll have to mix yellow and blue to get green, and things like that. So I'm not quite sure 100% how that's going to transpire, but it's very similar to what I've got going on here. I just wanted to play around with it a little bit, again, kind of as a freestyle, to just build on what I've been picking up in the last week and change. I'm pretty happy with the progress thus far. I think the pacing is pretty good. I know that they're trying to stretch it to 30 days, and 30 days is pretty good. Each lesson is between watching the video, writing the code, and me doing my video. It's roughly an hour of time, and it's just long enough where you can comprehend what you're picking up or what you're trying to pick up, I have learned quite a bit. I do think the pacing is pretty good. If I had one gripe, I would say that the narrator would have to cut back on the ums a little bit, honestly. If it were a little better scripted, I think it would be good. The content is there, the contexts are all there, but I think they are kind of freestyling the narration, and it should be more systematic, if you will. But that's just my opinion. I'll leave you guys to watch the videos and make your own conclusions. But I'm quite happy with what we've been doing, where we've been going. I am part of the Facebook group where people are posting up their projects and the things that they've been able to do since they've gotten out of the 30 days. Or actually, I was looking at a guy today that posted his kid wasn't even out of the 30 days. I think he was 21 days in. He already wrote his own version of Pong. So that was very impressive. He hooked up the OLED display and he just started crunching code, and he was able to make Pong, and he was able to use the rotary encoder that comes with the kit as a joystick controller to move the paddle around. So I thought that was fantastic. I'm hoping that I have half the results that this kid is experiencing 21 days into this. So that will conclude my video for today. And again, if you like the content, please be sure to like and subscribe. Hit the bell for notifications anytime I upload a video, which lately is pretty often. And if you feel generous and want to contribute to the future of this channel, please drop me a couple of bucks for coffee on my Patreon. If you want to check out my Amazon affiliate links or the Inventor.io affiliate link, there is a code in the description for 10% off of the Inventor.io kits. They are still currently on back order, but I do believe that they will be shipping in the next week or two. I was told that there was a delay even receiving my kit when I had just basically sent them an email asking if they would be so nice as to send me one. And even though there was a delay, it still showed up in a pretty quick amount of time. So don't let the back order deter you from pre-ordering. And that's me genuinely saying that. Don't let that stop you from pre-ordering. Check out the link. Use the code. Pre-order. Get your kit. Start your 30-day journey. I think that anybody that is interested in this should really consider getting one of these, following the instructions, following the additional material that's on the website, and learning about this stuff. I think it's fantastic. So that is all for tonight. Thank you for your continued support, and we will see you soon.